Before we begin our lesson, let's go ahead and look at a real world example. Here we can see the athletes on a lightweight crew team, and this is a picture of a crew team. Usually they're for different universities. It's a sport. They're athletes. The crew team must weigh 165 pounds or less. So if you weigh more than 165 pounds, you can't be on the team. So you have to weigh 160 pounds or less. The acceptable weights for these athletes can be described using an inequality. But before we start doing that, because we haven't even discussed what inequalities are, what are some possible weights for the athletes on the crew team? Well, if they cannot be any more than 165, they could be 164 pounds. They could be 150 pounds. They'd be 102 pounds. Try to think of some other numbers that they could be. Let's take a look at the objective for this lesson. We're going to answer two-part question. What is an inequality and how do we graph one? And this is going to be Chapter 3, Section 1 out of your Holt textbook. Here is the definition of an inequality and the symbols used. So an inequality is a statement that has two quantities, that are not equal. The quantities are compared by using the following sign. In Chapter 2, everything was equal, which is why they were called equations. But now, in Chapter 3, we're going to be dealing with inequalities. And inequalities have two quantities that are not equal. So you could say, in this case, let's look at A less than B in the red. A less than B, well, let's give it an example. How about 3, negative 3 is less than negative 2. Try to think of your own numbers for that. And when we graph A less than B, we're going to have to use an open circle. This is going to be an open circle. And normally we're going to graph towards the less than side, which is going to the left. Okay, let's go and look at A is greater than B. So here we have A greater than B. Let's think of two numbers that we could use. For example, we could say 7 is greater than 5. Right? 7 is greater than 5. Think of your own example for the numbers. This is also going to be used with an open circle to graph. And we're going to tend to go more to the greater side of the number line, which is to the right. Okay, let's look at A less is less than or equal to B. So two numbers that we can use would be negative 1 is less than or equal to negative 1. Right? Negative 1 is equal to negative 1. It's not less than, but it's equal to, and it can be. So this is a true statement. And when we graph this, we're going to use something called a closed circle. So we got to fill in our circle that we're going to use to graph. And we're going to tend to go to the left of the graph, less than. Let's go and look at A greater than or equal to B. So let's think of some numbers. So an example could be, let's see, 3 is greater than or equal to 3. Or we could say 3 is greater than or equal to 2. Try to think of your own example. And when we graph this, we are going to have to use a closed circle too. And we are going to go to the right of the graph when we're graphing. Now let me ask you this. Why do we have open and closed circles? Well, you can see that for the open circle, there's no bar underneath the inequality symbol. So for an open circle here, there's no bar underneath the inequality symbol. But when there is a bar underneath the inequality symbol, so in the example we have a bar here and a bar here, we're going to use the closed circle. So whenever there's a bar underneath the inequality symbol, you're going to use closed circle. And whenever there's not a bar, you're going to use an open circle. And you're going to see examples of this on the next slide. We never graph A is not equal to B, but when this happens, we call this a false statement. Some of you saw examples of that in Chapter 2. So a false statement is when it is not true when these two numbers are equal to each other. Okay? Normally that results in a no solution. So we put that no solution usually. Let's go ahead and describe the solution for this inequality in words. You just got to understand what the inequality is kind of telling us. So we're going to test some values. We're going to test positive, negative, and 0. And we're going to test it within this equation right here, this x minus 6. So let me go ahead and enlarge it a little bit more so I can write in these boxes. Make sure you pause and write down this table. So we're going to do negative 3 minus 6. And negative 3 minus 6 is negative 9. And we got to ask ourselves this question. Is negative 9 greater than negative 4? The answer is no, it's not. Right? Negative 9 is not greater than negative 4. Let's test 0. 0 minus 6 is negative 6. And we got to ask ourselves, is negative 6 greater than or equal to positive 4? Well, once again, no, it's not. 6 is less than that, so the answer is going to be no for 0. Let's go and test 9.9. Even though it's a decimal, it's pretty simple because we're going to subtract the whole number. So 9.9, excuse me, 9.9 minus 6 is going to be 3.9. Is 3.9 greater or equal to 4? Once again, the answer is no. 3.9 is not greater than or equal to 4. Okay, now let's test 6. 10 minus 6. So it's, which is 4. Is 4 greater than or equal to 4? Well, it's not greater than, but it is equal to, so yes, this is a true statement. Let's test. Okay, so let's do 10.1. We're going to go ahead and do 10.1 minus 6, which is going to give us 4.1, which is greater than or equal to 4. So this is another yes. And let's try a larger number like 12. So here we have 12 minus 6 is going to give us 6. Is 6 greater than or equal to 6? Oh, excuse me, not 6, right? That's supposed to be 4. Silly. Okay. Is 6 greater than or equal to 4? Yes, it is. So, by looking at this table, I can tell that solutions are going to be numbers 10, numbers that are greater than 10. Or equal to 10, right? 10 worked. So, any numbers that are greater than or equal to 10 is going to be a solution for this inequality up here, up top. Okay, let's now look at some more concrete examples. Here we have our first example, which is graphing this inequality. And all you're doing is graphing. You don't have to solve, you just have to graph it. So you want to go ahead and use a open or closed circle. Well, since there's a bar underneath the inequality symbol, we're going to do a closed circle. So I'm going to go to negative 3 on the number line, which is right here. I'm going to make a closed circle. And then I'm going to graph where it's less than negative 3. Where m is less than negative 3 is going to be towards the left. You can also color on the number line, or you can draw an arrow up. I saw students use both. Okay, let's look at another example. Here we're going to have to graph this inequality, but notice I'm going to have to simplify the right-hand side. So I have t less than, let me use black, t less than 5, and we always do what's in the parentheses. Negative 1 plus 3 is positive 2. And then we'll simplify that even further, so it's going to be t less than 10. Well, there's no bar underneath the inequality symbol, so I'm going to go to 10 and make it an open circle. And I need all values less than 10. All values less than 10 are going to be to the left again. And you can again shade on the number line, or you can shade, draw an arrow going above. Both ways are acceptable. Just make sure that you have that open circle. Now that we've looked at examples, let me give you some hints on how to read math when you're doing word problems with inequalities. So if you have no more than, the words in the word problem say no more than, then that means less than or equal to. So less than or equal to would be the inequality symbol. And if it says at least, this means greater than or equal to, so you're going to use the greater than or equal to symbol. And we're going to look at an example of that, or how to use this, the reading math, in the next slide.